Hello guys, welcome back with our Earth Space Science virtual learning and video lesson, I believe number 3. Hopefully you guys have begun to keep up with your notebooks or your note sheets as we go along here. Something before I begin the Go Blue that I thought of. I think some of the stuff I had posted yesterday was a little lengthy. Keep in mind this lesson regarding solar system formation was a fill in the blank. So to reduce the length of those words, I had it be a fill in the blank previously. Obviously, I can't provide you guys or have you guys print out, a lot of us at home, those sheets. So I am having you preferably write it from scratch, and then I simply just deleted a lot of the stuff and made it a lot shorter so it's easier to write. So let's go ahead and go to our desktop. Hope we're all doing well, doing solid here on this Wednesday, the first time we've been in the middle of the week with our e-learning. And let's see here, our Go Blue questions. As you guys can see my desktop there, we'll check out some old and new video clips. And oh, I've got the spinning wheel. Now it's gone, we're good. Okay, so if we look here, we've got 3 quick questions. Number 1, what are the key differences between laws and theories? Number 2, what are 2 examples of scientific theories and scientific laws? And 3, is one better than the other? And can theories become laws? So really rehashing those ideas we kind of finished on we finished up with the beginning of yesterday's lesson. Okay. As far as announcements, again, article question answers and unit quizzes are going to be on Friday. Okay. I think I also said on my video yesterday, I said notebook check quiz. Again, notebook check quiz isn't a separate quiz itself. It's me simply requesting 2 of the pages that we've done in our notebook within the past 2 weeks. So the notebook check, you're just going to take pictures of 2 pages I randomly asked for, and you send it with your names on them and your handwriting. With the unit quiz, that's actually an online EDSB quiz that we answer questions for over things we've talked about throughout the week. So again, have those on the lookout. Be ready to go on those. I'm seeing lots of people turn and submit in those article answers. So that's awesome. Again, if you are confused or need to know how to submit that stuff, you can look at yesterday's video. You go under pinned items, or you can look at the link. Look at the video from yesterday where I show you the submission link that is next to the post, where you are going to submit and attach a picture of your article answer questions. Okay. With that being said, let's go ahead and begin our Go Blue. Differences between laws and theories, 2 examples of each, and then is one better than the other? I've just put it down. The best thing we can always do, you guys know how much I like these, are T-charts, okay? So we go to our next, hopefully you have paused the video from here and answered it on your own. I've got my scientific laws on the left and my theories on the right, okay? And at the bottom, as you'll see there, kind of gives away one of our last questions there. Theories cannot become laws, right? And laws are not better than theories. They serve different roles for different topics in science, right? For descriptive topics, we're going to need to have a theory. It's the long text. It's the long text. It's the explanation. For laws, it is the mathematical, kind of the concrete idea, right? So I'm going to need an equation and a formula. Again, apples to oranges. Apples and oranges, they are not the same. So laws answers what? Super important to write this down, guys. I'm going to minimize my screen here. That way you guys can see all of this. Answers what? Whereas a theory is going to answer why and how, okay? Laws don't usually change. Theories are changed and can be adjusted and modified, as you guys can see here, okay? Then we have laws are going to predict results or phenomena in nature, whereas theory is just going to explain ideas, right? So explains ideas. And then as you can see with the GIF on the left side, laws are more math-based, whereas theories are more description-based. Again, some examples. Hopefully you thought of these. We've got, for laws of motion from Isaac Newton. We have gravity, thermodynamics, all physics-based topics, all things I can put into a math equation. Whereas theories are all things I have to describe. The Big Bang Theory, evolution, the heliocentric model. Can I put the Big Bang Theory into a mathematical equation? Can I put evolution into a theory, into a mathematical equation? The answer is no. Okay, it can't be put into a mathematical equation. They have to be theories. They have to be described and explained. Okay, so go ahead and pause that if you guys did not already. We can see those all there. And I was just about to say, any questions, comments, or concerns like I often do in class, but I realize we're all e-learning. I'm not in the classroom right now. So awesome job, guys. We are still on pages 9 and 10 with our table of contents. Again, everything you're writing down today can go actually on both pages 9 and 10, either one. If you need more room, you don't have enough on either one, you are going to be making a 10B. I will put on the quiz maybe a few things that were from before spring break, like the inner layers and the outer layers of the sun. So again, rehash that a little bit, just to rehash it, because I do think it's important, as we were going to start a unit test soon, but we can't. We're going to be doing quizzes. So some old stuff, I'm going to give you a heads up, that will be on, I think, the quiz. So be ready for that coming up here. Okay, our first question of the day. Centripetal force is most responsible for solar system formation. So is this the force, and as you can see, our planets and all of our asteroids and all things like that, is the centripetal force the most responsible for the solar system getting organized the way it is? Is this A, true, or B, false? Pause the video, take a moment to think. The answer is going to be B. Oh, do we not have an answer? Okay, well, not sure why we can't see that, but the answer is going to be B, false, because the main force that is going to change and determine how the solar system is organized is actually going to be gravity. Another test question case where you've got to choose the best answer, not necessarily where one answer is the only right one. There may be more than one that is right. There is centripetal force occurring a little bit, but your best answer, most specific, would be gravity, would be B, false, gravity. Okay. We'll get to the other question later. Not sure why. I guess I might have accidentally moved the answer slide on that. But hey, it happens. They didn't give away the answer. That's better than that. So let's go ahead. As you guys recall from yesterday, I'm going to rehash a few little things here. And actually what I want to do is go to share again. And I'm going to optimize or share computer sound for my video clips here. So hopefully that's in sync with that. Okay. So let's get back. I'm going to make things as quick as I can. Just so you guys know, on Fridays, on quiz days, I'm only going to make my video lesson 5 minutes. So I'm going to call it 5-minute Fridays, because I do want you to devote the majority of your time to the actual quiz. So all the days I've talked about with the review days, the test days, the group and test analysis days, which take the entire period, those are all gone now. So I need to give you guys that Friday, a super short lesson, so you can spend most of that time with the quiz that day. So just a heads up on that. I'll mention that again tomorrow. Okay, don't want to do that. I've already shared with the audio. Let's go ahead and go to full, keeping things as concise as I can here. I got like 6-7 minutes left. Okay, again, we talked about how do stars form, how do planets form a little bit, right? Hopefully you got into sync with the elements. Igniting, hydrogen, helium igniting with nuclear fusion, and that's going to ignite the star, and we're going to see the spinning, right, the centripetal force spinning about all those materials, all those asteroids that you see here, those rocks, just a ton of asteroids and gases just all mixed together, right? No planets at this point in time. So again, this was yesterday. The clouds of hydrogen, helium, the stars and planets are scattered all over into particles. So we see early solar system. No planets, no different types of planets, no asteroid belt. It's just a cluster of all this rock and all this gas, right? Kind of floating about, going around this central star, because the star is the greatest source of energy and force in the solar system, right? So we get the disk again, spinning about, clumping those things together again, just speeding through the old stuff just to refresh our memories, guys. Hearing it twice is always helpful. Okay. And that was where I believe we left off. And just to give you guys a visual here again, we get back right to this, right? Make sure my volume's not too, I know the video volume is usually a little louder than me. So, but just to get back into it, we can see Again, the swirling, there's that centripetal force, right? All those gases, all of those rocks, those asteroids moving about around that star, that early star, okay? And thus, again, the spinning top, this and that. And what I'm going to do is, let's see, does it have it here? I don't know if it's going to show what I wanted it to show. There we go. Okay, so there's more of the gases and the rocky materials have kind of clumped a little more there. So we're going to get back to that in a little bit. So let's get off to some new stuff. Again, I'm going to speed through this a little bit. So pause the video as you see fit. Hopefully, I've got like 3 or 4 slides here. Hopefully, I kind of condensed it a little better today. It's not as much tons of writing. Nah, okay. So again, this used to be fill in the blank, guys. I can't give you those sheets, obviously, physically, and a lot of you guys don't have access to printers. So even me, when my printer runs out of ink, it's like I'm kind of in trouble there. So and I don't even know. I'm not even sure Best Buy is even open right now for that printer, or Staples. Are those places even open right now? I'd have to double check on that one. Okay. So again, matter begins to condense. After the forces spin about, we're going to see the sun clumping together parts of dust. We have dust and heat at the center, pressurizing all the gases, right? Strengthening that star. Again, all we have is a baby star right now. It's just a little star kind of forming, igniting, strengthening itself, okay? And keep in mind, there's that disk, right, with the centripetal force we talked about. And the area, keep in mind with the star, it's the hottest part of the early solar system, obviously, right? So the area near the star is warm. The outer edges of this baby solar system, of this early solar system, are cold. Again, this stuff is going to be on page 10 or 10b, right? Preferably. If you want to put on 9. So here we go again, just to further illustrate the clumping together of this stuff, right? All coming about. All right. And I want to kind of show you a little visual here. Let me show you the visual. Let me see this here. Okay. So let's see. Did we have 2 matter condenses here? I think we did. Okay, so before I show you those Earth videos, again, it's your responsibility to watch those on your own. I'm just going to show you snippets of it, because if I show all videos, if I show too much, I think YouTube can get mad at you for that, and they can. I don't want them, turning my videos, having them be blocked or something like that. So I'm just going to show just bits and pieces of other people's others videos as we go along. But as you see the gases clump, that means also the solids are going to clump, right? So different parts are going to clump differently due to different areas of the solar system. Inner planets are going to have the higher melting point element. So all the rocks that can withstand the heat from that early star are going to survive and clump together into the inner planets. And then we'll see how the outer planets are actually different. So today, and then I think more tomorrow, we're going to focus on how our planets are so different. And how they came to be differentiated. And then lastly, guys, the outer planets are composed mostly of gases and ice. So inner planets, we've got high melting point rocks, okay? Because keep in mind, a lot of those asteroids and rocks, let me go back to the video clip here. A lot of these asteroids and rocks, they got pulled in to the sun, okay? They got vaporized and melted into the sun. But the strongest ones that stood the test of gravity, stood the test of the heat, they got to become Mercury. They got to be created into Earth, into Mars, into all the Venus, the rocky planets that we know today, right? And also, what divides the outer from the inner planets? We have the asteroid belt, as you guys know. Okay, so that's enough of that. Let's go ahead and check out a quick clip of how Earth may have formed. Again, I'll maybe show maybe like a minute at most of this stuff, but let's see kind of what they have to say here about early Earth kind of forming.
Collapses the cloud, turning it into a flattened, in a process known as the conservation of angular momentum. Gravity collapses the cloud, turning it into a flattened, spinning disk.
So clumping together that disk, right?
The powerful gravity pulls most of the gas into the center of the disk, and this gas gradually condenses, coalesces, and ultimately forms our sun. Leftover gas and dust swirls around and slowly begins clumping together.
The thing we just talked about, right?
Now the strong solar winds blast outward from the sun, blowing lighter materials like hydrogen and helium far out. Heavier material like dust and rocks resist the solar wind and remain close to the center. And it's this heavy material.
So again, as he mentions, those tougher rocks, those higher melting point rocks, kind of collecting near the sun, right? Those early inner planets.
That begins clumping together, eventually forming the prototypes of the inner rocky planets, including planet Earth. It's the Earth's dense, rocky core that forms first.
All right.
Heavy material.
So again, it's going to expand more on kind of the Earth specifically. I just wanted to focus on the inner planets. Really great video. I love these infographic kind of animation videos. They're always really great. So please watch the rest of that. Really informative, really helpful, really interesting there. And then I've also got an Earth 101 video that talks a little bit about earlier and Earth's formation as a whole. This runs down all the details of the planet. Really awesome there from National Geographic. You guys can watch that on your own as well. Okay, so let's go ahead and finish up here for the day. Okay, let's do our last question of the day before I finish this up with our stuff for the day. I'm going to try to keep things short, guys. Got a few minutes here. Let's see. Okay. Our last question from the other day. What two elements make up most of the early solar system? Is it A, hydrogen, helium, B, hydrogen and nitrogen, C, nitrogen and helium, or D, hydrogen and oxygen? And as you guys know, well, let's bring it back to the star or the sun. What two elements make up most of the sun? If you guys recall, it should be, pause this if you want. It's going to be A, hydrogen and helium. Those elements power the sun. It was the same elements that got the sun started in the first place. They clumped, as the video we just watched showed, right? Okay, that's our last question of the day. Let's go and finish up our last stuff we need to write for the day. We've got the inner versus the outer planets. So how are they different? What is separating those two things, right? We've got, as you can see, the asteroid belt being between the rocky planets and the outer planets. What also do you guys see? What is also another difference you guys notice about these planets? Take a look. Think for a moment here. Okay, the size, right? The gas planets, they're so much larger in size compared to the rocky planets. Hence maybe why they're called the gas giants versus our rocky planets here. Now, I've probably, so last thing of the day before we get into solar system formation are what's going to be called planetesimals, the last thing we're writing for the day. These were the form that the planets took before they were actual planets. So think of it like massive asteroids. You had asteroids actually clumping together into mini planets. We call these planetesimals. Not exactly planets yet. They didn't rotate perfectly. They kind of didn't have a perfect orbit just yet. Okay, so think of all this early solar system as a bunch of materials ready to separate and clump into separate regions. Kind of like if you guys ever see those vials of those different oils that you see scientists put, right, in those cylinders. And then eventually those different oils, they do what? They separate because they're different densities. The same thing happens to the planets. Our planets have all separated based on density, materials, all of those things. It's the same idea. So these tiny grains of particles clump together, forming planetesimals. And then again, we're talking hundreds of kilometers in diameter, still very large. Think of it like just a bunch of moons floating around and a bunch of gas around those moons before you could have like actual organized planets, right? So this is like, oh, you don't have it. It's not all dispersed and everywhere. Now it's kind of organizing, but it's still not completely set in place like it is today. And then lastly, our planetesimals, like I said, they are the precursors to planets. They would collide, as you see in this picture up here, and form our planets. All right, guys, that concludes our lesson for the day. Hope you guys are doing well. Again, I'll continue to respond to your questions, to your messages within a 24-hour basis. Again, make sure you've got we've got the article question answers due on Friday through EDSB submission on the article link. You've got our first quiz, again, 20 to 30 points, super important, going to be on Friday as well. We'll have a 5-minute lesson on Fridays because I want you to spend most of your time on those quizzes. And you guys are going to have, lastly, the notebook check next Friday. So hope you guys are doing well. Message me with any questions. Again, Mr. Campbell here, going to sign out. You guys have an awesome day, and I will see you guys tomorrow.